So in this video, we're going to talk about what we call our compound interest. And when we talk about compound interest is basically what happens now is instead of having our money, our interest compounded at looked at it just at the end of the year, we're actually going to look at interest at certain periods of time. And then money that we gain on that particular principal, the interest that we gain on that particular principal is going to be reinvested or compounded back into the actual principal to get a higher amount. Now, it's not going to be a whole lot because you're going to take your annual interest rate and you're going to spread it out over periods of time. But you are going to get a little bit more here. And so interest paid on interest reinvested is called compound interest. And the compound interest formula is just this. We say A is equal to P times 1 plus. Now we're going to take the rate and we're going to divide it by a new variable, which we'll call N. That's the compounding variable, raised to the N times T, where A, again, is your ending balance or your final amount. P is what we call our principal or the initial investment or the initial loan if you take out a loan. R is the rate again, and this is still expressed as a decimal. N is a new variable that we're going to call the compound. And compounding is tells me how often I actually reinvest my interest. And then T is going to be my time, still expressed in terms of years. So we have different compounding periods. And in general, when we talk about these compounding periods, we talk about a compounding period of annually, that just means we're going to do it one time. Semi-annually means 2 times. Weekly means 52. Monthly, there's 12 months. Daily for compounding is 365. And quarterly is 4. So these are most of your common compounding periods here. So when you see those are going to be my new ends. So as an example, it says, suppose $1,000 is invested into an account paying 6% annual interest compounded monthly. So literally what you're going to do now is you're going to take this 6% and you're going to spread it out over 12 months. And because you're spreading it out over 12 months, then you're actually going to have a little bit more because you're compounding on more money each month. How much is in the account at the end of 1 year? So here we have, you're taking 1,000 as your initial investment. So here's your P. And it's going to pay 6% annual interest. So your R is 0.06. But you're compounding that interest monthly. So your N is equal to, monthly means 12. And they want to know how much is going to be in your account. So you want to find how much is in the account A over 1 year. So that's your T. And so when we use our formula says A is equal to P times 1 plus my rate R divided by my compounding period N raised to the number of compounds I'm going to do for the number of years that I do it, NT. So if I want to find this, A is equal to P, which is 1,000, times 1 plus my R is 0.06, divided by my N, which is now 12, raised to the 12, and T here is just 1. So T here is just 1. And so when we calculate this, again, we always calculate the inside of this first. And in particular, we're going to do this fraction here. So we're going to divide 0.06 divided by 12, and I get 0.005. I'm going to add that to 1. So the inside of this, it's going to set up like this, then A is equal to 1,000 times 1.005. And I'm also going to calculate this 12 times 1 up here. And 12 times 1 is just 12. So all of that raised to the 12. I'm now going to work this part next right here. So I'm going to take 1.005 and raise it to the 12th power. And notice when I do that, I get a number that is really close to 1. It's a little bit bigger than 1, by the way. But it's still kind of like 1. It's just a little bit bigger than it. So A is equal to 1,000 times. And this new number I'm getting is 1.061677812. I want to take as many decimals and be as accurate as I can for this. I'm going to take that and multiply by 1,000 next. and I get a final compounding or a final amount of $1,061.68. And for these problems, you always want to end it in two decimals because we're talking about money. And so when we talk about money, we always want to talk about cents. That's why we're rounding to the second spot here. So in these examples, let's actually compare what happens as we change compounding periods. So for this one, it says, find the amount to which 1,500 will grow at simple interest. And remember, our simple interest formula is just A is equal to P times 1 plus RT. And here my P is, I'm putting in 1,500. And I know the interest rate is 0.0, R is equal to 0.0675. And my T here is equal to 10. So when I calculate this A, this ending balance, I'm going to get this here. 1,500 times 1 plus 0.0675 times my T, which is 10. And so again, I'm going to work this part first. And when I do that, I get 10 times 0.0675, which is 675. So I get A equal to 1,500 times 1.675. If I multiply 1,500 times that 1.675, I get 2,512. I get $2,512.50. And so notice here, if I started out with this amount, $1,500, after 10 years at this particular rate, I've grown to this amount. So in interest alone, which is I, in interest alone, we just take this value and subtract it from the original value. So minus 1,500. And I can see that in interest alone, I've gotten $1,012.50. So that's at annual interest compounding one time a year, or simple interest. That's what it literally is. So now we're going to compound it over quarterly payments. Look at quarterly payments this time, right? And so when I look at it compounded quarterly, the new formula I'm going to use is A is equal to P times 1 plus R over N, because I'm compounding, raised to the NT. So A is equal to 1,500 times 1 plus, my R is still 0.0675. But I'm going to divide that by my quarter compounds, which is 4. I'm going to raise out that to the 4 times the T, which is 10. So again, I'll work everything inside of here first. And when I do that, do 1 plus 0.0675 divided by 4. I get A is equal to 1,500 times. This becomes 1.016875. And I'm also going to calculate this part up here, 4 times 10. That's raised to the 40th. And so when I raise this number inside of here to the 40th power, I get A is equal to 1,500 times this new number. When I raise it to 4 is 195,300,2554. And if I want to solve for A now, I just multiply that number by 1,500. And I get A equal to $2,929.50. And again, if I want to calculate the interest that I've gained on that compounding quarterly, I just subtract that from 1,500. And I see that my interest, I, is equal to $1,429.50. So if you notice here, when you compound it quarterly, you got almost $400 more than when you did it like that, when you did it simple. And then the last one says, well, let's compound it even further. Let's compound daily. Let's do it every day. So again, we know our formula is A is equal to, we're going to use the P times 1 plus R over N raised to the NT. So A is equal to 1,500 times 1 plus, my R here is 0.0675, divided by my N, which this time I'm compounding daily. So that's 365 raised to the N, 365, times the T, which is 10. So this time when I calculate 1 plus 0.0675 divided by 365, I get a very small number that's bigger, a very small number close to 1. So it's 1,500 times, and I get this number here, 1.000184,932. If you compare this number right here to this number when we compounded quarterly versus when we compounded annually, notice that this number right here is getting smaller. This growth rate is basically getting smaller. It's getting smaller, but it's going to occur more often. Because now if I do 365 times 10, I'm going to have 3,650 compounds occurring in this particular period. So when I take that number that I just got right there, and I raise it to the 3,650th power, I get this number here. So A is equal to 1,500 times 1.963910411. I'm going to multiply that times 1,500, and I get a value of $2,945. And so A is now equal to $2,945.87. And again, if I want to find I, if I want to find my I here, I just subtract off that 1,500 that I started with. And here, notice my I is, my interest that I've gained on that is $1,445.87. So notice that as I compound more, I'm going to get more interest. I'm going to gain more interest. So the more I compound, the more I gain. And that's how we do these problems here. In interest alone. So in these videos, we're going to show how to find different values within the compounding formula. And the first one is how to find the principal. So it says, how much should you invest now at 10% to have $8,000 toward the purchase of a car in 5 years if interest is compounded quarterly? So again, we're going to use the formula A is equal to P times 1 plus R over N raised to the NT. And here they're telling me they want to know how much should you invest. So that investment, that initial investment is P. They want me to find P. And they're telling me that my interest rate is 10%. And I want to have $8,000 at the end. So basically as a down payment. So I want that ending balance to be 8,000. And it needs to be done in 5 years. So my T is 5. So we're going to do is plug in what we know, and we're going to solve for that P. So 8,000 is equal to P, which we don't know right now. That's 1 plus my R, which is 0.1, over my N. And remember, we're compounding here quarterly. So my N has to equal 4. And it's raised to the N, which is 4, times the T, which is 5. And so again, I'll work the inside of this first. So I get 8,000 is equal to P times 1 plus 0.1 divided by 4. That's equal to 1.025. I'm going to raise that to the 4 times 5, which is the 20th power. So I'm going to raise that to the 20th power. And here I get 8,000 is equal to 1.63861644 times the principal P. If I want to solve for P, I'm going to divide everything by that 1.63861644 on both sides. So when I divide that 8,000 by that, I get a principal. I have to invest principal of $4,882.17 as my initial investment to reach my goal here. So that's how we solve for the principal variable. Let's solve for the time variable next. How long will it take $10,000 to grow to a $12,000 if it is invested at 9% compounded monthly? So again, I wanted to know how will it take 10,000. So I start off with 10,000. This is going to be my principal. To grow to 12,000, that's my A. Interest rate here is 9%. So that's 0.9. Compounded monthly means my N is equal to 12. So when I do this, I'm going to do 12,000 is equal to 10,000 times 1 plus R, which is 0.09, divided by N, which is 12, raised to the 12 times my N. And I'm looking for T this time. I don't know T, so this will be 12T. So when we solve this, we're going to go ahead and first, anytime we're given the A and the P, we will always divide by P first. I'm going to divide both sides by 10,000 first. And divide both sides by 10,000. 12,000 divided by 10,000 gives me 1.2. That's equal to, I'm also going to clean this part up inside of here as well while I'm doing this. So that's 1 plus 0.09 divided by 12. When I do that, I get 1.0075. I'm raising all of that to the 12t. Well, here's what happens now. If I want to solve an equation with an exponent, solving equations with exponents, I have to use logarithms. In this case, I'm going to use a natural logarithm. And natural logarithm has a nice property that says when you multiply something by a natural log, or when you introduce a natural log, the exponent will always move to the front of it. So I'm going to do the natural log of 1.2. That's equal to here's what happens. This right here moves to the front. So that becomes 12t natural log of 1.0075. And now what I can do is I can try to solve this equation for this t variable. Notice I have the 12 thing in the front, and then this natural log of 1.0075. This part right here is just a number, and it's a number your calculator will calculate for us. So we're just going to divide everything by everything that's not t on this side. So I'm going to divide by 12, natural log 1.0075. Do the same thing over here. I'll divide by 12, natural log 1.0075. And I'm doing it like this because I want to have exact answers. So my calculator, I'm going to do natural log of 1.2 divided by, I'm going to use another set of parentheses. I'm going to do 12 times the natural log of 1.0075. When I do that, I get t is equal to 2.033. So this is 2.033 years in terms of my time.